presenting. Sorry, I thought there was somebody else before. So I'll just start by mentioning this is the work from many people. I'm just here, the one presenting, but there was a lot of people in the water and then out of the water processing the data. And I'd like to start by acknowledging the traditional custodians of the sea country where these data were collected and where we meet today. So as you all know, corals have a symbiotic relationship with algae, and when they get stressed, the symbiotic relationship is broken and they expel the algae from the coral, so that's when we see the white skeleton underneath. The main reason for this, or the most usual reason, is when temperatures exceed what the corals are used to, and this is exacerbated by high light intensity. But there are other factors that affect how corals bleach, or the proportion of corals that bleach. So depth is one of the factors that has been looked at more closely. As you go down the water column, you would expect slightly colder temperature and less light intensity, so it's thought that it should ameliorate the bleaching. And there's lots of studies on this, but there's studies presenting both patterns, so where the bleaching decreases with depth and also where it increases. And it's very taxa dependent as well. Another factor, important factor here, is water velocity. So as you get more faster water flow, the mass transfer between the toxic byproducts of the bleaching and the water column is easier. So it's thought that it should be less proportion of colonies should bleach when there's high water flow. And again, there's been studies looking at this, and the patterns have been shown in both directions as well. Taxa, I think there's been a lot of effort here. So there's the winners and the losers, the constant winners and the constant losers, and then lots of variation in between. And these changes within a site, within a species, and also between the different studies and the different bleaching events. And the last one that I'm going to talk about today is colony size. So most of the effort has been looked at comparing what the juveniles are experiencing and the adults are experiencing, and less so kind of the range, once they're already adult, how does colony size affect bleaching? But in general, recruits or juveniles bleach less than the adults. So as I mentioned, there's lots of effort that has already been done, and we're still finding high variation. One of the limiting factors here is the time spent underwater. So obviously when you're down there, you can only record so much data. So photogrammetry can help us get capture the patterns on a much broader spatial scale, and then do all the time consuming bits kind of the water when you're not so time limited. So that's what we did in April 2022. So this was a mild bleaching event in the central Great Barrier Reef. And Katerina already showed us kind of how the different sites were laid out, but I'll go through it a little bit again. So we had 4 different reefs. The Palm Islands kind of our inshore reef, and then we had Chicken, Davis, and Little Broadhurst in the offshore reefs. And then each reef had sites all along the periphery at 5-meter depth. And then the Palms and Davis Reef had also sites at 12-meter depth. Each site had the 4 plots that Katerina showed, and in total we had 104 plots. So this is an example of one of the orthomosaics and a little zoom in of the colonies. So once we were out of the water, we traced the colonies so we could get colony size estimates, and then we labeled them according to the bleaching. So there was kind of no bleaching, minor bleaching, from up to 50% of the colony was bleached. Then major bleaching, which was from 51 to 95, and then anything above that, including whole colony mortality, was labeled as severely bleached. And we looked at a range of different factors, some of the ones I mentioned. We also looked at other factors that I won't have time to go through them today. So this is kind of a subset of what we found. So the first thing that was surprising, the degree heating weeks. So for those of you who might not know this, it's a metric of the bleaching stress. So basically, the longer and the higher the temperature relative to the temperature that the corals are routinely exposed to during summer, the higher the degree heating weeks. So most of the studies find a really steep curve there. And we did find a positive relationship. It was not very weak, but if you can see I don't know if the numbers are big enough, but the variation there is not too high. So it goes from 4 to 5. So basically all of our sites were experiencing a very similar bleaching or thermal stress. And then in terms of water velocity, our patterns differed between the inshore and offshore reefs. So in the inshores, we saw that decline in bleaching susceptibility with water velocity, which was the one we were expecting, but not so much in the offshore. And the offshore did tend to bleach a lot more than the inshore, which kind of makes sense because it should have higher light intensity due to less turbid water. And one of the things here to consider is that the water velocity we had to extract from maps, so model wave data, and summarize through time. So it might not really reflect what the corals were experiencing at the time of the bleaching event. And here I just showed any bleaching, so I didn't divide it by different categories because they were all behaving really similarly. In terms of taxa, we got some of what we expected. So for example, Ceratopora hystrix, Stylophora pistillata, they're usually on the losers category, whereas the Priorities massive, they don't tend to bleach as much. The one that was kind of surprising was the Acropora table, which didn't really bleach that much in our study. And this was in contrast to what Paul Marshall and Andrew Baird found in the Palm Islands on the 1999, whatever, bleaching event. So that was the category of the most severe taxa, severely bleached taxa. So I'm not sure what's going on here, but observer bias is not likely to affect the ranking at least, because it was just one person. And in terms of colony, the effect of colony size, you can see there's positive relationships, no relationships, and negative relationships, depending on taxa. But if we looked a little bit more closely to the different bleaching categories, so minor bleaching usually increased with colony size, whereas severely bleached corals decreased with increasing colony size. So I think this suggests that the larger adults are a bit less susceptible, and they were kind of on the way to showing the effects of the stress, whereas the little ones had already gone through it and they were already on the severely bleached categories. In terms of depth, there were various relationships depending on the taxa, but the signal wasn't super strong. And this kind of makes sense because we were looking at 5 to 12 meters depth, so the range wasn't as big as some of the other studies. And just to wrap up, photogrammetry was a very useful tool for us because, first of all, it allowed us to target different taxa that we were not initially planning, and it obviously helps with getting the colony size estimates. And from here, the next step would be to look at how the bleached corals differed in terms of growth and survival with the non-bleached corals. So that's probably the next step where this data set is going to go. And we found lots of variation in bleaching. We obviously didn't look at the symbiodinium identities or the genetic component, which I think Zoe Messier from Cynthia's lab was going to be looking at. And just to put this in perspective, the results I showed here, there are kind of like size refuge and some taxa that didn't show susceptibility to thermal stress. But we were on the yellow, from that map, the yellow bit is where this bleaching event was at. This is the map for this year. So it's not looking as good this time around. And this information will hopefully help when we decide if which taxa and where to do any of the interventions. This information might help some of those decisions. And with that, thanks to everyone who helped along the way.
Thank you very much. Do you have any questions from the audience? Yes? Yeah, if you'd like.
Can you talk a bit about how would you use that relationship between size and bleaching susceptibility in restoration and management? How would that sort of change your decisions, knowing that relationship for this? And I think because it's different in different species, makes it very different.
Yeah.
So the question is, how will you use this knowledge about the relationship between bleaching and size tolerances to inform how can that be used in future management or restoration?
Yeah, that's a great question. I think, so some of the talk is at what size should you deploy the juveniles or the recruits? And obviously the longer you keep them in the tanks, it costs a lot of money, and also you might be getting some effects of the tank or just being held in captivity. So ideally you want to deploy them as fast as possible, but for some taxa that showed that the smallest ones are much more susceptible than the larger ones, that might be a compromise where you might target some species to grow a little bit more in the aquaria before you deploy them. But yeah, I think there's a lot of things to play. Yeah, it would be pretty expensive. I agree.
And what drives that correlation between size and bleaching susceptibility?
Yeah, that's a great question. If you have any ideas, we'll love to hear about them. I think for in the opposite, yeah. Sorry.
Old people bleach their hair. But the vigor of young people and the vigor of young corals is obviously part of it. And what determines the vigor? I don't think I need that. Okay.
It's for that we have lots of people watching online, so they can't hear unless it's
okay.
in the microphone.
So the vigor of youth, I mean, it's obvious to me, but with disease, we find that the small corals succumb much worse to disease than the large ones in our sites. And my question was, is it a factor of size? I mean, if you break up a coral of the same genotype into different sizes, would the young ones be more resilient in the initial stages, and would the old ones be more resilient if the bleaching continues and continues and continues? Has anybody done anything like that, looking at the same symbionts and genotypes, and then you break it up and see what happens?
So like having the same colony and then seeing if you break it into different sizes, does the susceptibility change? Yeah, I'm not aware of anything.
It might not be age, it might be size.
Yeah.
Final question from the audience.
Hi, so with regard to the size effect that you found, I thought, maybe I misheard, but I thought you were alluding to the fact that the size effect could be confounded by past experience. In other words, the larger colonies have been through more, and so they're carrying that kind of latent effect that the small colonies didn't have.
Yeah, it is possible that they've experienced, like they're the survivors of previous bleaching events and then they're less susceptible, but I think it's all kind of speculation at this point, yeah.
Right, thank you very much.
Thank you.
Sounds like there's a lot of interest.